Textiles, a prominent tradition in both cultural and industrial context in India. Dominated by medium, small and micro enterprises, the sector accounts for 5% of India's GDP. A textile unit involves 4 key processes: fabric pre-treatment, dyeing, printing and drying and finishing. Fabric pre-treatment involves bleaching. It cleans natural color and produces a white product for further processing. Dyeing adds color to the fabric. Bleaching and dyeing happen at elevated temperature for a long duration, and the system is less efficient. The jet dyeing machines or the bleaching machine drain water into the common effluent treatment plant or CETP at a temperature of 70 to 90 degrees Celsius. The result is wastage of vast quantities of heat energy. The installation of waste heat recovery systems can tap this heat energy, which would otherwise go waste. The system operates using a heat exchanger, a pipe and pipe type heat exchanger consisting of concentric tubes. The inner tube carries the discharged waste water at elevated temperature. An outer tube carries fresh water. Required baffles are provided in the fresh water flow to improve heat exchanger efficiency. The water flow in counterflow direction for effective heat exchange. The waste water temperature at inlet of the heat exchanger is around 90 degrees Celsius. The fresh water entering at ambient temperature gain the heat and attain a temperature of around 55 degrees Celsius at heat exchanger outlet. This preheated water is fed into the process, saving a considerable amount of energy. The water flow and pressure is maintained by hydro-pneumatic system, eliminating the requirement of a water pump. The proposed technology enhances the efficiency by utilizing the generated heat water in the process or as boiler feed water, hence reducing fuel consumption, reduces the process time, prevents thermal shock in boilers by reducing the load on equipment. The total cost of installation of a waste heat recovery is estimated around 6 to 8 lakhs. The resulted coal savings are estimated at 80 to 100 tons per annum. The simple payback period works out to be around 1.5 years. The intervention can lead to a saving of around 40 to 50 tons of oil equivalent of energy. The monetary benefit is estimated at 3 to 4 lakh rupees per annum and around 170 to 180 tons of carbon dioxide emissions annually.
Heat exchanger is a very good concept, and it should be used so that we keep on saving lot of energy, it's even a benefit to the company in terms of amount. It's on terms of rupees, it's a benefit. It's not all, it's one of our basic advantages environment. At the second, it is also helpful for the industry itself. So I think it is a good concept, and every other industry should adopt this concept of heat exchanger.
The pipe material reacts with the chemicals in the dye and corrodes it. Any leakage in the pipes will lead to contamination in the freshly pumped water. This will affect the dyeing or bleaching process, which can impact the energy. Thus, the waste heat recovery system should be regularly checked to avoid such issues. Also, material of the heat exchanger should be selected accordingly. The technology leads to saving of energy coupled with low temperature wastewater, which is an environmental requirement. If implemented in 100 units, the technology can save around 4,000 tons of oil equivalent of energy and around 17,000 tons of carbon dioxide emissions annually.